Hello dear students, this is your physics teacher Ashish Sharma and in this lecture we will discuss about dimensional analysis. This is first lecture of dimensional analysis. For continuing the entire syllabus of physics, please follow my YouTube channel and you can also follow True Education Point for making your physics better. So let us start. So what are dimensions? The dimensions of a physical quantity are the powers or exponents to which the units of the base quantities are raised to represent a derived unit of that quantity. Example, velocity. We know that velocity is defined as displacement divided by time, and displacement is a length and time is a time, one of fundamental quantities, so their dimensions are L divided by T. So dimensional formula of velocity is Lt minus 1. Similarly, we can write acceleration. We know that acceleration is velocity divided by time. So dividing the dimensions of velocity by dimensions of time, we get the dimensional formula of acceleration, Lt minus 2. Force is defined as mass into acceleration. So multiplying the dimensions of acceleration with mass, we get dimensional formula of force. Similarly, energy or work is defined as force into distance. So multiplying the dimensional formula of force, that is mlt minus 2, with distance, that is L, it becomes ml2t minus 2. Power is defined as work done per unit time. So dividing the dimensional formula of work, that is ml2t minus 2, divided by dimensional formula of time, we get the dimensional formula of power, ml2t minus 1. So Lt minus 1, when we write it in like this square bracket form, it is known as dimensional formula. So Lt minus 1 is the dimensional formula of velocity. What is a dimensional equation? When a quantity is equated to its dimensional formula, it is known as dimensional equation. For example, we know that Lt minus 1 is the dimensional formula of velocity. So when I will write like this, velocity is equal to Lt minus 1, this is known as dimensional equation. Dear students, we use variables and constants in study of physics. Both variables and constant, they can be dimensional or dimensionless. So we can have dimensional variables like force, acceleration, pressure, etc. And we can have dimensional constants like speed of light, which is a constant. It is a dimensional constant. We know that dimensions of velocity are Lt minus 1. Universal gravitational constant, which you have studied in your class 10th in gravitation chapter. Sorry, it was in your 9th class gravitation chapter, and in class 11th you will also study gravitation. Then we are having dimensional variables like angle, strain. तो आपने फंडामेंटल क्वांटिटीज़ में पढ़ा होगा कि जो एंगल है वो सप्लीमेंट्री क्वांटिटीज़ में आता है, फंडामेंटल क्वांटिटीज़ में नहीं आता, क्योंकि ये इसकी डायमेंशंस नहीं है. रिलेटिव डेंसिटी इज़ अ रेशो, ये भी आपने 9th क्लास में पढ़ा होगा आर्किमिडीज प्रिंसिपल पढ़ते हुए. ऐसे ही रिफ्रैक्टिव इंडेक्स जो है वो भी डायमेंशनलेस होता है. डायमेंशनलेस कॉन्स्टेंट्स कौन से हैं हमारे? जैसे प्योर नंबर्स हमारे 1, 2, 4, 5, 6, 7 एट्सेट्रा. 3 भी आ जाएगा बीच में, कोई कन्फ्यूज़न वाली बात नहीं है. जितने भी हमारे सारे नंबर हैं, और पाई और ई हम पर्टिकुलर यूज़ करते हैं एज ए बेस ऑफ नेचुरल लॉगरिथम. इसके बारे में हम बाद में पढ़ेंगे. तो जो भी हमारे कॉन्स्टेंट्स हैं जिनकी वैल्यू फिक्स है, हमारी मैथमेटिकल नंबर जैसे पाई, √2, √3 एट्सेट्रा, तो ये सारे हमारे जो हैं डायमेंशनलेस कॉन्स्टेंट्स हैं. फिर उसके बाद आता है हमारे पास प्रिंसिपल ऑफ होमोजेनिटी. व्हाट इज़ प्रिंसिपल ऑफ होमोजेनिटी? According to principle of homogeneity, only that formula is correct in which dimensions of various terms on one side of relation are equal to dimensions of respective terms on other side of relation. यानी कि जिस भी रिलेशन में लेफ्ट हैंड साइड की डायमेंशंस राइट हैंड साइड की डायमेंशंस के इक्वल होंगी, सिर्फ वही फॉर्मूला करेक्ट होएगा हमारा. इसे हम बोलते हैं प्रिंसिपल ऑफ होमोजेनिटी. हमारे पास 4 एप्लीकेशंस हैं डायमेंशनल एनालिसिस की, एंड दीज आर checking the correctness of formula, converting one system of units into another system of units, deriving the relation between given variables, and the fact that same quantities can be added or subtracted. We will discuss first two in this lecture and the next two in other lecture. So checking the correctness of formula, let us have a numerical example. Check the correctness of relation t is equal to 2 pi root L by g, where t is time period, L is length, and g is acceleration due to gravity. So writing the relation, writing dimensions on each side, t has dimensions t only, 2 pi is dimensionless quantity, and the square root means power 1 by 2 as we all know. So we can write it like L divided by L t minus 2. So L and L will get cancel out, and t from denominator where it has power minus 2, when come in numerator it becomes power plus 2, and then it's having square root, or we can say half, so it becomes t. So as dimensions on left hand side are equal to dimensions on right hand side, then by the principle of homogeneity of above relation is correct. So that is how you can check the dimensions of so many other relations. There are so many examples in Pradeep's book. Let us discuss converting one system of units into another system of units. Converting 1 Newton into dynes. We know that Newton is the unit of force in MKS system, or we can say SI system, and dyne is the unit of force in CGS system. CGS is centimeter gram second, MKS is meter kilogram second. So we know that both quantities are representing force, so dimensional formula of both quantities are same, MLT minus 2, MLT minus 2. Anyhow, for distinguishing, we represent by subscript A, we are representing MKS system, and by subscript B, we are representing CGS system. For calculating n, this formula from right hand side will go in division of formula in left hand side. So small n is equal to ma by mb raised to power 1, la by lb raised to power 1, ta by tb raised to power minus 2. Putting the values of ma, la and ta from respective systems, A is representing SI system, so mass is 1 kg, length is 1 meter, time is 1 second, while B is representing CGS system, so mass is 1 gram, length is 1 centimeter and time is 1 second. 1 second से 1 second cancel हो जाएगा, and writing kg in grams we can write 1000 gram. We are doing it so that कि ग्राम से ग्राम कैंसिल हो सके, इसलिए हमने kg को ग्राम में लिखा. फिर 1 मीटर को हमने 100 सेंटीमीटर में लिखा ताकि सेंटीमीटर से सेंटीमीटर कैंसिल हो जाए, और 1 सेकंड से 1 सेकंड तो वैसे ही कट जाएगा, और 1 की पावर माइनस 2 1 ही आएगा. तो इस तरीके से हमारे को स्मॉल एन की वैल्यू मिल गई 1000 इंटू 100, 10⁻³ इंटू 10⁻², that is 10⁻5. So now we know that 1 Newton is equal to 10⁻5 dynes. As a homework, you can also solve for 1 joule and convert it into ergs. Erg is the CGS unit of work, while joule is the SI unit of work, and your answer will come 10⁻7 ergs. You can solve this, or you can also solve like converting 54 kilometer per hour into meter per second. By solving the same method, you will get 15 meter per second. Okay, so try these examples and I'll see you in next lecture. Thank you.